Assalamu alaikum students, hope you're doing good. This is lecture for grade 10th physics, and in this lecture we will cover unit 11, that is sound. So we are going to start the lecture number 5. Now the topic today we will discuss is noise pollution. So for pollution we will discuss the two different types of sound. One sound that is a pleasant sound which has a very good effect on our ear, and the other sound that has a bad impact on our ear, and or a sound that we don't like to hear, that is a noise sound, right? So the pleasant one is a musical sound and the other one is a noise sound, and in this regard we will discuss noise pollution. Such sounds which are pleasant effect to our ears are called musical sound. However, some sounds produce unpleasant effects on our ears, such as sounds of machinery, slamming of doors, and sound of traffic in big cities. So some sounds, they have a very good effect on your ear whenever you switch on the television or radio, and if there's some kind of music is playing, you like it very much, and because it has a very good impact on your ear, and we call the sound which has a very pleasant effect on our ears, we call it a musical sound. For musical sound we use a different kind of instrument. It can be flute, harmonium, guitar, etc., right? However, there is also a sound which has a very bad effect on our ear, and that sound is a noise sound. For example, if you hear the voice of a machinery, so sometime when some work is going on at your home or your workplace, and you hear the voice of a machine, what will happen? You will get irritated. It has a the noise of the machine is disturbing to you. The second example is slamming of a door. If someone shortly close the door or window, what will happen? It will, and you are sleeping or you are busy some like this, so what will happen? You know it will be a very bad effect on your ear. So this is a noise sound. Sound of a traffic in big cities. Whenever you are stuck in a traffic and there's a sounds of traffics of different vehicles, right? So it has a very unpleasant effect on your ear. That is a example of a noise sound. Sound which has jarring and unpleasant effects on our ear is called noise sound, right? So jarring is basically a harsh sound. Noise corresponds to irregular and sudden vibrations produced by some sounds. Obviously, noise sound is again the same. Its production is like sound that when things start vibrates, it created a sound. So noise correspond to irregular and sudden vibrations that are produced by some sound. So if you want to control the sound, or there are basically the two levels of the sound. Two levels of the sound on depending upon the factors. Number one is the level volume of the noise. So if the volume or level of this noise is low, might be it cannot irritate our ear, but if we raise the same noise to a very high volume or very high level, this noise can be irritable, right? And the period of exposure to sound noise. So similarly, if the period of a noise is very long, it will be effect on our ear, and it create irritation to us, right? So these are the two factors of the level of a noise. The level of noise recommended in most of the countries is usually 85 to 90 dB over 8-hour workday. So this level is recommended, and we can bear this level of noise. Noise pollution can be reduced to acceptable level by replacing noisy machineries with environment-friendly machinery and equipment, putting sound reducing barriers, or using hearing protection of devices. So there are some instruments by which we can we can reduce this sound, and these can be that we can use some kind of machinery that can be that can be put the sound reducing barrier, so the noise of the sound cannot be reaches us directly, right? Or we can use a hearing protection of the devices that we put some instrument in our ear, so we cannot hear the sound of a noise. So this is the noise pollution. So now we will discuss activity 11.4. Develop an action plan to help you address any problems with noise in your workplace. Consider the following points. Describe the problem. So first of all, we have to describe the problems, and we take the example of industrial noise pollution, right? So this can be a topic for a problem. Then what are the sources of the problem? The sources of the problems can be metal fatigue in machinery. Who are the people being affected? People can be employees, to those who work there, workers, labor class that are working in the industry. Your suggestion of the solution. So the suggestions can be provide reduce noise to acceptable level by replacing old machinery with a new one. Reduce noise level by putting sound barriers. Make environment friendly for employees, worker and labor. Use hearing protection devices such as ear plug. Sound displays all the properties of waves when it's interact with materials and boundaries. Let's say if the surface is very hard and very smooth, reflection can be take place. This is the incident wave, and this is the reflective wave because the surface is very smooth and rigid. Now in case of refraction, the surface can be soft and porous. If the surface is porous and soft, what will happen? The incident ray come over here and it can be passed through this surface and the refraction take place. Similarly, if we see the diffraction, the wave is coming there in like in this direction, so between it will pass from this place, it will be split like this. And in case of absorption, what will be happen? If the surface is very smooth and so, irregular shape, it will be absorbed by that surface, right? So this rays come inside and it is absorbed inside this material, right? So these are the properties of wave that when they interact with different materials and boundaries. Importance of acoustic. So acoustic is basically a property of sound that we'll discuss over here. First of all, we have to know what is acoustic. The technique or method used to absorb undesirable sound by soft and porous surfaces is called acoustic, right? Reflection of a sound is more prominent if the surface is rigid and smooth. There will be a more reflection, but reflection will be less if the surface is soft and irregular. Soft porous materials such as draperies are basically, you can say, the cloths and curtains, and the rugs absorb quiet echoes and softening noise. So that's why when sound reflect from the walls, ceilings and the floor of the room, the reflecting surfaces are too reflective and the sound becomes garbled. So when sound becomes garbled, it will be very difficult for us to hear a proper sound, because garbled sound is a unclear sound. So why this happens? This is because the multiple reflection of sounds occur, that is known as reverberation, right? So if you see the figure 11.1, there's a curve. So why the curved ceiling of a conference hall is made? Because they are made curved because sound after reflection may reach all the corners of the hall, right? And sometimes curved sounds broad are placed behind the stage. So if you see the figure 11.2, it is like this. They are placing behind the stage so that the sound after reflection distributed evenly across the hall, right? So these are the examples of acoustic. It's a property of a sound, right? Now we will discuss about audible frequency range, at what frequency can we listen, right? We know that sound is producing by a vibrating body. A normal human ear can hear a sound only if the frequencies lie between 20 hertz and 20,000 hertz. So 20 hertz is a minimum range and 20,000 hertz is a maximum range that human ear can hear a sound. In other words, a human ear neither hear the sound of frequency less than 20 hertz nor a sound of frequency more than 20 hertz. Different peoples have different ranges of audibility. It also decreases with the age. So as our age increases, our listening skills can be or might be decreased because of our health. So if we see the young children, they can hear a sound of a 20 hertz, but similarly, if we see the old people, they cannot hear even above 15 hertz. So it also depends upon the age of a human being, right? The next topic is ultrasound. Sounds of frequencies higher than 20,000 hertz, which are inaudible to normal human ears, are called ultrasounds or ultrasonic. So these sounds cannot be heard by a human. Ultrasounds or ultrasonic, right? So now we will discuss the uses of ultrasound. Ultrasonic waves carry more energy and higher frequency than audible sound waves, as they are more than 20,000 hertz, so they have a more energy and obviously they will have a higher frequency than the normal sound that the human ear can hear. So therefore, according to the wave equation, V is equals to F lambda. The wavelength of ultrasonic wave is a very small and is very useful for detecting very small objects. Ultrasonic are utilized in medical and technical fields. Also, hear the words of ultrasound that is mostly common used in the medical fields and technical fields. Also, in medical fields, ultrasonic waves are used to diagnose and treat different alignments. For diagnosis of different disease, ultrasonic waves are made to enter the human body through transmitters. These waves are reflected different by different organs, tissues, or tumors, etc. The reflected waves are then amplified to form an image of internal organ of the body on screen, that is shown in figure 11.3. If you see the figure 11.3 of your book, it is clear. This figure suggests an image help in detecting the defects in these organs. So the next uses are powerful ultrasound is now being used to remove blood clot uh, formed in the arteries. Ultrasounds can also be used to get the pictures of thyroid gland for diagnosis purpose. So now there is no need to do some kind of a large kind of operation to remove a blood clots. We just remove these blood clots from the arteries by the help of using ultrasound. And similarly, if anybody have a thyroid gland and there's some issues regarding this, so it can easily be diagnosed by using ultrasound. So the next use is ultrasound is used to locate underwater depth, or is used for locating objects lying deep on the ocean floor, etc. So if we want to know about the depth of a water, it can be easily recognized by using ultrasound, right? This technique is called a sonar. Sonar stands for sound navigation and ranging. The sound waves are sent from a transmitter and a receiver collects the reflected sound as shown in figure 11.14, right? So this is the board that is shown in figure. This is the water surface. Here in at the bottom, detector and transmitter, they are placed, and by the help of these, when these rays are sent into the deep into the ocean, their depth can also be recognized by using these ultrasound wave, and then receiver can collect these reflected sound by using data collector, right? The time lapse is calculated knowing the speed of a sound in the water. The distance of the object from the ocean surfaces can be estimated. So the last use of ultrasound that is mentioned in your book is again sonar. The other purpose of sonar is ranging, is also used to see the shape and size of the object. Then germs and bacteria that are present in the liquid can also be destroyed by using high intensity ultrasonic waves. So we can destroy these kind of germs. Now we are going to start the lecture number 6. So now we will do the exercise questions that are MCQs. Choose the correct answer from the following choices. Number 1 is which is the example of a longitudinal wave? Sound waves, light waves, radio waves, and water wave. So the right option is Option A, that we have discussed, that sound waves are also a longitudinal wave because of their direction and propagation. How does sound travels from its source to your ear? First option is by changing in air pressure, by electromagnetic waves, by vibration in wires or string, by infrared waves. So the right option is by changing in the air pressure. Which form of energy is sound? Electrical, thermal, mechanical, chemical. So the right answer is a mechanical. Astronauts in space need to communicate with each other by radio links because sound waves travels very slowly in the space. Sound waves travels very fast in the space. Sound waves cannot travel in the space. Sound waves have low frequency in the space. So the right option is option C. Because astronauts in space, they need to communicate with each other by radio links because sound waves cannot travel in space, right? So this is the right answer. So the fifth is the loudness of a sound is most closely related to its frequency, wavelength, period, and amplitude. So the right option is option D. If I have a greater amplitude, there will be a more loudness, right? So it has a direct relation with amplitude. 6 is for a normal person, audible frequency range for sound waves lies between 10 Hz and 10 kHz, then 20 Hz and 20 kHz, C is 25 Hz and 25 kHz, D is 30 Hz and 30 kHz, and the right option is B, 20 Hz to 20,000 Hz, that is kilohertz, right? When the frequency of a sound wave is increased, which of the following will be decreased? Wavelength, time, period, amplitude. 1 only, 1 and 2 only, 3 only, 1 and 3 only. So the right option is option A. Only when the frequency of a sound waves is increased, only the wavelength will be decreased, right? This is the problem of 11.2 of your book. If at Anarkali Bazaar, Lahore, intensity level of sound is 80 dB, what will be intensity of the sound there? So first of all, sound level is given to us and the intensity we have to find out. Use the formula intensity of sound level is equal to 10 log I by I naught dB. So sound level is given 80 dB, so we put 80 dB over here. 10 log I is unknown, divided by I naught is always 10 power minus 12 that we have discussed in the very previous lecture, right? So just we simplify it, putting the values. This 80 and 10 divided by 10, it will get 8 is equals to log I by 10 power minus 2, then 8 is equals to log I minus log 10 minus 2. Here we will use the property theta is equals to log I plus 12 log 10. This is again the formula that we have to use over here. 8 is equals to log I plus 12 into 1 because log 10 is equals to 1. So log I plus 12, so we'll take 12 on the other side I. So 8 minus 12 gives you 4 is equals to log I. If you take the anti to 0.0001 meter watt per meter square, if we want to write in the power, it will be 10 power minus 4 watt per meter square. Problem 11.3. At a particular temperature, the speed of a sound in air is 330 meter per second. So the speed of sound is 330 meter per second. If the wavelength a note is 5 centimeter and wavelength is given that is 5 centimeters, so first of all we convert centimeter into meter. So we have to divide 5 by 100 and we will get 0.05 meter. Calculate the frequency of the sound wave. So we have to find out the frequency of sound wave. Is this frequency is audible range of the human ear? So we also have to check that whether this frequency that we are going to calculate is in audible range of human ear. So the solution for this is we use the formula frequency is equals to speed by wavelength. So the speed is given that is 330 meter per second, wavelength is 0.05 meter. Just divide them, we will get 6.6 into 10 power 3 hertz, which is equals to 6600 hertz. So this frequency is lies audible range of human ear, that is 20 hertz to 20,000 hertz. So the problem 11.4 is A doctor counts 72 heartbeats in 1 minute. So the number of heartbeats is 72 and time is 1 minute. So if we convert minute into second, it will be a 60 seconds. Calculate the frequency and period of the heartbeat. So we have to frequency and period is basically a time period. So frequency, they are total the number divided by time period. So number of heartbeat divided by time, right? So number is 72 and time is 60. So when you divide it, we will get the frequency. And the time period is a reciprocal of the frequency. So t is equals to 1 by f, t is equals to 1.2, t is equals to 0.83 seconds. 11.5. A marine survey ship sends a sound wave straight to the seabed. It receives an echo 1.5 seconds later. The speed of sound in seawater is 1500 meter per second. Find the depth of the sea at this position. So speed of sound is given to us, that is v is equals to 1500 per meter per second. Time is t is equals to 1.5 second, and we are going to find out the depth, that is d is equals to, that we are going to find. So we will use the formula d is equals to vt. So for an echo sound travel, the total distance will be d plus t, that is equals to d, because one time it's taken for the incident sound, then it will be reflected back. So this t and this t will give you the 2d. So the total distance will be 2d. So by putting the values in this equation, we will get 2d is equals to 1500 into 1.5. So just simplify this. When you take 2 on the other side, we will get t is equals to 1125 meters. So this is the depth that we have find out. So the problem 11.6 is a student clapped his hand near a cliff and I heard the echo after 5 seconds. So the time is given, that is 5 seconds. What is the distance of the cliff from the student? So we have to find out this distance. If the speed of a sound is taken as 346 meter per second, so speed of sound is again given, which is v is equals to 346 meter per second, right? So by using the formula d is equals to vt, and we know that for equal sound wave travels, the total distance will be d plus d, that is equals to 2d. One time when it's go, sound will travel, it's take measured in time d, and when it come back, then it will be again the distance. So these two d give you 2d. So putting the values in equation 1, we will get 2d is equals to 346 into 5, 2d is equals to 1370. So we have to take 2 on the other side, we will get d is equals to 130 by 2, that is equals to 865 meter. So 11.7 is a ship sent out ultrasound that returns from the sea bed and is detected after 3.42 seconds. So 42 seconds is basically a time. If the speed of ultrasound through sea water is 1531 meter per second, so this is the speed. Speed is represented by v, that we write over here. What is the distance of a seabed from the ship? So we have to find out the distance. You know the formula that distance equals to speed into time. So as the ultrasound travels, the total distance will be s plus s, because one time it will be go, another time it will come back, so total time will be 2s. So 2s is equals to v into t. So 2s is equals to, you just put the values and just simplify it, and we will get s equals to 2618 meter. So problem 11.8. In this problem, the highest frequency of a sound human ears can be 20,000 hertz. So we write this is the highest frequency represented by f1. What is the wavelength of a sound in the air at this frequency at a temperature of 20 degrees centigrade? So we have to find out this highest wavelength represented by lambda 1. What is the wavelength of a lowest sound wave can hear of about 20 hertz? So again we have to find out the lowest sound wave, that is lambda 2, and its frequency is 20 hertz. As the speed of a sound in air is 20 degrees centigrade is 343 meter per second. So we have right, the speed is 343 meter per second. So we use a simple formula, v is equal to f lambda. We have to find out the lambda. So lambda is equal to v by f. So lambda 1 is equal to v by f1. Just put the value and we will get 1.7 into 10 to the power minus 3. For same formula, just change lambda 2 is equal to v by f2. So to put the value in, we will get lambda 2 is equal to 17.2 meter. 11.9 is a sound wave at the frequency of 2 kilohertz. So we have frequency is given, that is 2 kilohertz, which is equals to 2000 hertz, and wavelength of 35 centimeters. So we have to convert 35 centimeter into meter, so we have to divide 35 by 100 and we will get 0.35 meter. How long will it take to travel 1.5 kilometer? So how long it mean that we have to find out the time, and the distance given to us, that is 1.5 kilometer, that is equals to 1500 meter. So we will use the formula V is equals to frequency into wavelength. Wavelength is written as lambda, that is equals to 2000 into 0.35, that is equals to 700 meter per second. Again, by using the relation D is equals to Vt or T is equals to D by V, we will find out the time. So we will put the value T is equals to 1500 by 700, that is equals to 2.1 second. So this is the end of lecture. If you have any confusion, you can ask me in WhatsApp group as well in GC. Thank you so much, and Allah Hafiz. And also you have to do all these problems in your notebook. Allah Hafiz.